You'll definitely want to take notes. Okay? So solving polynomial equations is in 274 to 278 in your book if you need a reference. I switched up the calendar a bit just because there are some. Is anyone going to be gone in here on Thursday? A couple people possibly. Okay. So we're going to teach 6.5 tomorrow, the first day of it at least. And then we'll be reviewing this again. We'll be doing more of this same stuff on Thursday. So if you're going to be gone Thursday, make sure you talk to me. But you also get your practice test for this chapter tomorrow. We don't have a practice test day this chapter, so it's something you kind of have to go through and do on your own. And we'll go through questions, but I'll discuss that tomorrow. Okay. So the other thing to know, up there on the board, all work and retakes are due Friday the 16th, which is next Friday. That means that will be our test retake day in this class. If you're going to do a retake, you need to request that retake with me by the 14th, which is next Wednesday. You're taking your Chapter 6 test on Tuesday. I will do my very best to have those back to you on Wednesday. Okay? So I will be working hard to get those graded so you can determine whether or not you need to retake that. You'll have portfolios due next Friday. So Friday really is your cutoff date next week of getting everything in. If you're going to use your portfolio in your final, it needs to be done by next Friday and needs to be turned in to me. We'll discuss that a little more next week, but I do have portfolio books for you guys to put those in. Your main thing is to get your portfolio page for polynomials done as soon as possible. Those of you that still have them out, for other ones, you should get those done. Those are also quizzes. When we talk about final exams, we'll discuss the rest of that. But Friday's a big date for you guys next week. All right. So if you recall from factoring, any questions on the test stuff? Okay. If you recall from factoring, on the back of your note page today, it gave you this. Okay. It's just a quick review. You've seen this page before, but just so you have it again in front of you. Factor out a monomial always if possible. So for instance, 2d squared minus 16, you can pull that 2 out. And when you pull it out, 2 times d squared is 2d squared, and 2 times 8 is that 16 there. Okay, once you're done, count your remaining terms. If there are 2 terms, look for a difference of 2 perfect squares. If the front term is a perfect square and the back term is a perfect square and there's a subtraction sign in between, that's the difference of 2 perfect squares. Okay, square root of 2 or a 4d squared is 2d. Square root of 9 is 3. So it's 2d minus 3 and 2d plus 3. The reason that works out is when you multiply these two things out, that gives me 4d squared plus 6d. And then when I multiply here times here, I get that minus 6d. So by having that plus and minus, these two pieces cancel in the middle, and I'm just left with the fronts and the outs. Okay, so that's a minus 9 back there. So I get 4d squared minus 9. Okay, it's a little tougher to see. If there are 3 terms, look for perfect square trinomials if you're good with those. If not, you don't have to look for perfect square trinomials. You could just skip right down to here, which is where you use general factoring, the box method or Lizzie's method for those of you that are familiar with that. 2 things that multiply to make that and add to that. Or if there's an A term where you multiply A by C, 2 things that multiply to make there and add to that. Okay, if you can't factor, we call it prime, and we have to use another method, for instance, quadratic formula, maybe your calculator or completing the square. Okay? All right. There's some other stuff we referenced when we talked about solving these. Okay, so if we're using factoring, one of the things we talked about was to count how many times x appears in your equation. So if you're looking at it, if x appears more than once, if x appears multiple times, it's different than if x appears only once. So it seemed to help out for you guys to count the number of times x appears. Okay? If you count how often x appears, that may help you out here. Okay? If x appears once, just pull out a greatest common factor. Okay, so an example of that might be y equals 4x squared minus 2. Okay? But actually, if x appears once, use just inverse operations. I'm sorry, not pulling out a greatest common factor. Use inverse operations. We make y equal what? 0. Okay? We're trying to find, remember when we solve for factoring, we're trying to find our x-intercepts, where it crosses the x-axis. Okay? And that's when y is 0. So we solve here, we just add 2 to both sides. Divide by 4. And then take the root. Okay, so if x only appears once, just use inverse operations. Right? If it appears more than once, but it doesn't have a constant. Okay, tell your neighbor what a constant is. Okay, remember your constant is like a number without a variable, 2, 5, 7, anything like that. So if you have, for instance, y equals negative 2x to the 5th plus x cubed. Okay, so x appears more than once, but there's not a constant. In this case, just factor out a greatest common factor. With x in it. Okay, it should contain x because x appears in both of those and there's not a constant. Now if there's like a plus 5 back here, right, I don't want you to write this in, but on mine I'll write it in. Let's say I have plus 5. Okay, if I have that plus 5, I can't pull out an x now because there's no x with this one. Okay, so that's why we're going without a constant. Right, so x appears more than once. It appears in every term. Okay, in this case we're going to set that equal to 0. We're going to pull out an x to the third power, and x to the third times x squared is x to the 5th, and we keep that negative 2. X to the third times 1 is x to the third. Don't forget that 1 there. Okay, and now you could solve. This gives me 3 zeros. 0, 0, 0, or 0 with a multiplicity of 3. This one we set equal to 0. Negative 2x squared plus 1 equals 0. So negative 2x squared equals negative 1. X squared equals 1/2. X equals plus minus root 2 over 2. Okay, or the square root of 1/2. Right? Okay, any questions there? All right, so the next one is x appears. X appear multiple times, but it has a constant. Okay, so it appears more than once with a constant. Okay, in that case, for instance, maybe you have y equals x squared plus x minus 6. Okay, the options here, you could factor. You can use the quadratic formula. Remember, the quadratic formula works in all. It works for all. You can use completing the square. You can use graphing. Probably on your calculator would be the easiest. All of those. Okay, if you can factor, that's the quickest way. And if it doesn't have an a term, it's even easier with factoring, right? You look at just the c then and go, well, two things that multiply to make negative 6 and add to 1. So in this case, that would be positive 3, and negative 2. We've now factored. That gives me an answer of x equaling negative 3 and x equaling positive 2. Okay? That is the process I'm hoping that you are very comfortable with right now. All right? If you are not very comfortable with that, then you really need to spend some time on it, because that's kind of where I'm assuming we're at as a group. All right? Going into today's stuff. That was a very, very quick review. Any questions there? We've had some special cases, which we'll go through again today. We'll do a quick review on some. I want to work through problems, but I'm putting myself at a time limit. By 10 o'clock today, you have to be working on your assignment. So we're going to get through what we can. So here we go. Actually, I might use that. All right. So I want everyone to write down a couple problems. First one is, this is not off your assignment. All right. These are just problems we're going to work through in class. So these go on your notes here or on a separate sheet of paper, wherever you want to reference them. But number 2, okay, and then number 3. Go ahead and copy them down and then tell your neighbor how you're going to solve both of them. Don't actually solve them. You don't have to solve them quite yet, but at least tell them how you're going to start them. All right, here we go. So what are we going to do on number 2? Hannah? Greatest common factor. Yeah, we count it. We look at it. First of all, it's equal to 0. That's a nice hint for us, meaning that we don't have to move anything. So we can just look at these pieces. Okay? And then looking at them, there's z's in each of them. So we can take out a greatest common factor. In this case, we can pull out a z. Okay? It's the lowest degree of z. So it's to the first. There's no constant in front of this one, so we can't pull out a number. So z times what is z cubed? Z squared. Z times what is negative 4z squared? Negative 4z. And z times what is 3z? 3. All right, and that equals 0. Okay, so we now have this. Question? You know what to do next? Okay? Someone else this time. Not that we'll come back to Anna later. Yeah, Tyler?
You factor the quadratic equation in the parentheses.
Good. We can get an answer. We can get one answer from this. What answer is that? 0. Okay? So from this, we have to set that part equal to 0 now. And that means we have to try to factor that or use the quadratic formula. Why? Because it's a squared and it has multiple z's with a constant. So in this case, we can factor it. Two things that multiply to make 3, because since there's no a term, well, the a term's 1, we just look back here. Multiply to 3 and add to negative 4. Okay, so negative 1 and negative 3. All right. This answer gives me 1, and this one gives me 3. So there are my 3 answers. 0, 1, and 3. Z equals a set containing 0, 1, and 3. Questions that came up the other day, does it matter what order you put them in? No. However, numerically is usually how you'll see it. Another answer that came up, or a question that came up is, how are we sure there's 3 answers? How do I know there are like more answers? Well, because this is a cubic. Remember, that tells you how many possible solutions you can have. You could have fewer, okay, but you can't have more. Yeah?
Are we worried about restrictions yet?
We're not doing restrictions, no. Thank you. Yeah. Questions? How many got it? Okay. Next one, number 3. How are we going to solve that one? This one was kind of those weird ones. Yeah, Parker.
I would factor it, but instead of in the parentheses, put x squared instead of x.
Okay,
So
good.
Treat it like a regular quadratic equation.
Good. So x appears multiple times. It's set equal to 0 already, so we're just focusing on this side. X appears multiple times. There's no x back here. Now, the reason we can factor, how do we know we can factor here? Tyler?
Because one is a number that's however one is called, but it's a perfect exponent or something.
Perfect square.
Doesn't necessarily have to be a perfect square. It's comparing this and this. What does the relationship here have to be?
You can both take out a square root, or
Okay. That's not quite, yeah.
The second one is half of the first one.
The second power is half the first power. Like if this was 6, this would have to be 3. If this was 12, this would have to be
6.
Okay, if that relationship appears, then you can factor it. And the way we're going to think about it is we're going to say this is x squared squared. We now have a quadratic here. Right? We have something, let's pretend we don't know what's in there, squared. Just like over here, we had that z squared. Okay, well now we have something squared. Let's pretend we don't know that there's an x squared in there. And then minus 5x squared to the first power. You guys with me? Okay. And then that's plus 4. All right, and you know what, I think we should probably put our parenthesis there. Okay. Excuse the mess there. All right, so we have x squared, quantity squared, minus 5 times x squared to the first plus 4. All right, so we now have a quadratic. This is to the second power, this is to the first power. Two things that multiply to make 4, since a is 1 out here. Two things to multiply to make 4 and add to negative 5. What are they? Negative 4, negative 1. Okay? And those two things, we now have to put whatever was right here. So in this case, rather than just having x, since the thing that we're squaring is x squared, we put x squared there and x squared there. Question?
I didn't when I did it, I didn't do all that stuff above, it just seemed like I could bring it straight down into, does that work?
Did you get to here?
Yeah,
Okay, that's fine.
okay.
Yep. There's other ways to think about it. In fact, I went through it a different way with this class earlier this year.
Oh.
Then it confused some people, so I went through it another way. So this is the mathematical way of how to do it. And there will be other teachers that actually use substitution. They use f of x, g of x. I'm not going to do that. I think that will confuse you more than anything right now. Okay, are these my answers?
No.
No, we need to set this equal to 0. X squared minus 4 equals 0. Okay? That is a binomial. A binomial, you should always look for what? Perfect square. Is that a perfect square? Is that a perfect square? Difference of two perfect squares, right? The pattern is x and x. Square root of this is 2 and 2. And in between we have plus minus. X plus 2, x minus 2 equals 0. And this is x plus 2, or excuse me, x plus 1 and x minus 1 equals 0. This gives me a solution of? Yeah, negative 1 and positive 1. And this gives me a solution of negative 2 and positive 2. Now, we can write that like this. And some of you would even argue that's a waste of my time. Why would I do that when I could just take x squared minus 4 equals 0 and just add 4, get x squared equals 4, and then take the root? How many of you did that instead? Yeah, and that's fine. The only reason I go through this right now is because Chapter 8 is approaching very quick. And if you get this, when we're dealing with rational functions, you have to be able to factor this, not find solutions to it. So you need to know that you can factor that to here. Know your difference of two perfect squares. Okay? But either way works. You do the same thing here and get plus minus 1. Questions? Everyone rate themselves 1 to 5. All right, moving on. Number 7. Tell your neighbor what you're going to do. Okay, time's up. What do I do first? Connor? Combine like terms. That means put everything together. And we also need to set it equal to 0. So by combining like terms, we're going to take care of that setting equal to 0. I'm going to move the 2y cubed over there. That's going to give me y cubed, right? So we subtract that 2y cubed. So we get y cubed. I'm going to, gives me 0 there. I'm going to add 2y squared over. That gives me, good, yeah, negative 3y squared. And then plus 2y. All that's now equal to 0. We know what to do from there? There's a y in each, right? Yeah, we take out that y. Okay, tell your neighbor one of your solutions. Good, you get an answer of 0 from that one right there. This part, y squared minus 3y plus 2, you have to set equal to 0 and trifactor. Two things that multiply to make 2 and add to negative 3 are? Good. This gives me a solution of?
2 and 1.
Okay. Those are my values for x. Or for y, I guess, in this case. Questions on it? Looks pretty messy up here, right? You guys, we just went through that problem in about a minute's time. Okay? You guys are hopefully getting faster at that. Okay? Tell your neighbor what you're doing on 20. Gabby, you should really slide over and maybe talk to them too. Yeah. They'll be nice. Maybe. I don't know. All right. Time's up. Volunteer. What do I do? Kidding?
Take out a greatest common factor of 2x.
Good. There's x in each, so we can take out an x. And in this case, we can take out that 2 as well, because 2 goes in each of those. Okay? When I take, how many said 2x? I heard a bunch of you say it, but, okay? 2 times what is 12? 6. X times what is x cubed? Good. 2 times what is 2x squared? 2. Negative 1 and x. And then, yeah, I need to put that negative 1 back there. Even when this is the same as that, make sure you put that place value holder. That's a negative 1. Okay, you're multiplying by it. I guess it's not really a place value holder, but you need to have a number there. Okay? Tell your neighbor one answer, one solution. Okay, we should get a solution of what from that? 0. From this, we have 6x squared minus x minus 1 equals 0. Now this is a little tougher. Why is this one more difficult?
Because there's a is not 1. Right?
Yeah, we got that 6, right? So tell your neighbor what you have to do to factor that. All right, so a times c, 1 times 6, we get negative 6. Right, we've got to multiply that by that. Two things to multiply to make negative 6 and add to negative 1 are?
That would be 3. Negative 6 equals 3 and 2, which is
2 and negative 3. Okay, 2 times negative 3, multiply to make negative 6, your a times c. And then add to negative 1. Now, when a is 1, we don't multiply the 2, right? Like, when we were factoring this over here, a was 1. So we didn't worry about going 1 times 2 to figure out what that was. We just, I mean, when a is 1, it's easy. We just find two things to multiply to make that and add to that. When a is not 1, remember, you've got to multiply these two, negative 6, and then find out what goes to that. In this case, it's here. And then what do we do? Yeah?
You divide by 6.
Yeah, you got to divide by your a term, okay? So divide that by 6, divide that by 6. Reduce gives you 1/3, and reduce gives you negative 1/2. We good on that? Any questions up to there? Hannah?
I was taught a different way to do it, where you have your
'Kay.
x minus 3 and your x plus 2,
Uh-huh.
and you write that down.
You write it in here first?
Yep.
Yep.
And then I divide by negative 6, and then you reduce it, so you have 1/2, and then you move that 2 in front
Yep.
of the x.
Yeah, and I know a lot of students really like doing it that way, and that's usually how I show it. So that way works as well. You could do the division in here. And really, if you do that, your answer, your solution, is right there, right? I mean, if those two things multiply to make 0, then this is one of your solutions, 1/2. This is another one, -1/3. And then you've got your third. So those are your three solutions. The only reason I'd want you to go through and actually show the factored process, because the factored form of this, you pull the 2 in front, pull the 3 in front, you get 2x minus 1 and 3x plus 1. But then you've got to undo it again to get back to here, just so that you know how to factor them. Okay? But those are your solutions. X equals 0, 1/2, and -1/3. Yeah?
Up on the top, when you did the 2 times -3 then divide by 6,
Mhm.
you got -1/2 and 1/3.
Right. Which
It should be
That's, it
negative.
should be -1/3 and 1/2.
You got it right on the bottom, but you just really
Yeah.
wrong up there.
Oh, up here did I write it wrong?
Yeah.
Yeah.
Did I do that wrong?
I think you got that one.
Where did you write that one?
It says -1/2, and it should be -1/3 switched by -1/3.
Oh, yeah. You switch the 2 and the
Oh,
3.
yeah.
Or the negative.
No, for your answer,
I'm
it's
so
switched.
confused.
Because you have the positive -1/2 on top, and then you have a -1/2 on top. And
Yeah, those are right.
Oh, because you
I
switched.
think that's
Yeah.
how you do it.
Yep, that's right.
You're right.
Those are correct. Yep.
Like, what are you talking
Yeah, these won't be the same as these, if that's what you're. Yeah, they'll be opposite. Yeah. Okay. Other questions? Guys, I'm a few minutes behind, and I had 2 more problems. I want you to look at those while I'm just real quick, see if there's any burning questions that come up on them. I'll put up the answers while you guys are working on today's assignment, but just kind of glance at those, see if there's anything like you're like, I'm not sure what to do on this one. Okay. But first, are any questions on these? Like, what do you do first? Okay, I'll put up the answers here in a minute, but your assignment today is this worksheet. You can choose 8 problems to skip. 8 total problems to skip. It's your 8 total. So you choose which ones. Okay? I will tell you on number 27 and 32, you cannot factor those. So you can also cross those 2 out. 27 and 32 you can cross out, and then you can skip 8 other problems. Okay? All right.
Okay. Oh, I got that first. I like it. I should put it. So 27, 32. You have to skip these 2, and you can skip 8 additional. So 27, 32. And then you can skip 8 others.
There's number 23 for those of you who are wondering. You guys, on your test, you will have problems like number 24. So as you're choosing which ones to skip tonight, these ones with the 4th power, after you put this in standard form, set it equal to 0. These ones with the 4th power, I wouldn't choose to skip all of these. Okay? Otherwise, you're going to struggle on your test if you don't practice them. Mitch?
It was 27 and 32.
27 and 32 don't factor. Okay, so you can skip those 2. Two things that multiply 8 and okay. Make sure we divide by 8.
So then you get x equals negative 3 and 4.
Okay, so.
Hey, ladies and gentlemen, there is that last one, number 24. If you want to see the work on it, I'll focus it in. A little more involved. Okay, ladies and gentlemen, taking a look up here. Hey, this is number 4. Hey, the question came up on this one. You pull out an x, and you find that one of your solutions is 0, and then you factor this, and you get x minus 5 times x minus 5. Well, x minus 5 times x minus 5 is x minus 5 squared. So you can pull out, you would end up with 2 5s here, right? Okay, in your answer, you only have to list one of those 5s. Okay, unless the directions specifically state list the multiple zeros. Now, if there says list multiple zeros, then you would have to say 0, 5, 5, because it's asking for multiplicity then. But when it just says find the solutions, your two solutions are 0 and 5. Okay? You clear on that? Okay. So if it says list multiple zeros, then you'd have to list 0, 5, and 5, because it would be appearing more than once there.